Welcome students to one more session of your general organic chemistry. So we have done in the previous video the conformers of ethane. I have clearly explained the different concepts like your Sawhort's projection form, Wilson representation, Newman projection representation. Then I've taught you what is SKU conformations. I've also given you the information based on dihedral angle. I've given you information based on torsional strain, torsional energy, what is that energy whenever using that. And I've also given you the order of staggered conformation, that what of stability of staggered conformation, Newman projection conformation, as well as SKU conformation. We also said among all the three, staggered is the most stable. Least stable is eclipsed form because atoms are very close by. Done. Today we'll be learning about conformations of propane and conformations of butane. Done? Yes. So here I'll be drawing the Newman projection conformations, Newman projection conformations for propane. So when we see Newman projections, I think you would have clearly understood how we will represent, right? I'll be drawing the eclipsed form for that, and I'll be also drawing the staggered form for this. Done. So in the Newman projection eclipsed form, right? So both you have to show this, right? So we said there are two, front carbon atom and the rear carbon atom. Correct, right? So this is propane molecule. So first CH3 is here, hydrogen, hydrogen. Now at the rear carbon, this hydrogen very close by. In eclipse they will be close by. You have to remember that. Hydrogen. In staggered they're equally spaced. CH3, hydrogen, hydrogen. This is the hydrogen, one more hydrogen. That's it. Simple, isn't it? So rotation, where does it happen? It happens between C1 and C2 carbons. So let us write that. Rotation around C1 and C2. Done? Fine. So now we'll be learning the conformers of butane, right students? I told you I'll be showing the conformers of butane. I'll be showing you the conformers of cycloalkanes also, right? So now let us come back and write the heading conformers of butane. So 4 carbon atom, isn't it? Butane is a 4 carbon alkane. So let us write. So here again I'll be showing Newman projection only. Let us write that. Newman projections. Done. So in case of butane, so as I said, 4 carbon atom, how should we start? First, Newman means you have to show this. Then, yeah. Right. So the first different one, CH3, H and H. Now when I draw the rear carbon atom, CH3, hydrogen, hydrogen. Now this is which one? This is the first one. Let us name this fully eclipsed. Fully eclipsed form. Now we are going to do or show 60-degree rotation. But which one? Between C2 and C3. Rotation is between C2 and C3. Let us write that. Rotation between C2 and C3. In the earlier one it was between, as we have done, C1 and C2. Now C2 and C3. When it is rotating, how does this look? CH3. Yeah, see here, 60 degree. Okay, first this hydrogen I have to write. One more hydrogen, one more hydrogen. So this is the second part. This is called gauche or gauchy. Some say gauche, gauchy, gauche. Yes. Now the same, this one, I am going to rotate it to 60 degree again. How does this look? This is rotated to 60 degree. So you're rotating it like this. So you're right. So first here hydrogen comes here because you're rotating this part, isn't it, like this. So this hydrogen comes here. and the CH3 group comes here, one more hydrogen here. So yeah, this part is over, isn't it? Now we have rotated like this. H, the CH3 has come here. H, we still have the second carbon. So one more CH3 comes here. So one more H here, one more H. Hope this is clear, students. See here, we have rotated this part. It's come here in this way. This also has moved down. This also has moved down here. So the leftover is here. So this is third. We call this as partially eclipsed. Partially eclipsed. Further, I am rotating to 60 degree. Now, this looks hydrogen, hydrogen, CH3. Further, I am rotating. CH3 is here, hydrogen is here, hydrogen. Hope you are understanding, students. I am not able to show it here. Just analyze, imagine it. So this is the fourth one. We call it as anti-staggered. Anti. So again, staggered. Anti-form, but it is staggered because equally spaced. Now I'm going to take this and rotate it to further 60 degree. Okay, I'll further rotate it to 60 degree. How does this look like? This looks like hydrogen, 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 CH3, hydrogen, and CH3. This is the fifth one. This is called partially eclipsed. Further, we'll rotate this to 60 degree. Finally, we get okay, I think this is wrong. Okay, I'm striking this off. I'm sorry for this. Let us draw it properly. I'm sorry for this. Okay, I'm rotating further 60 degrees, isn't it? It has to come like this. Yeah, this is right. Please cross this. This is right. CH3, H, CH3, CH3, H, H. This is the sixth one. This is again called Gauche form. Some say Gauche, one say Gauche form, that way. Right? Right, students? Right. Now let us write the stability order for this. Stability order. Right? For the stability order, see, 1 is less stable than 3. 3 is less stable. Okay, not less stable, it is almost equal. 3 is in equal stability with 5. 5 is less stable than 6. No, not 6. I think, yeah, 5 is less stable than 2. Then 2 is almost equal to 6 less than 4. Let us write what we have written. Let us see once again. We said the first one is less stable than 3. Okay, what is that? Fully eclipsed is less stable than 3. That is partially eclipsed, which is almost equal to the fifth one, that is partially eclipsed, right? Which is less than Gauche, which is approximately equal to 6 because both are 6 forms, and which is less than 4, that is anti, that is nothing but staggered form, that is nothing but staggered. So hope students it is clear. Staggered is equally spaced, fully eclipsed. There's a lot of torsional strain. That is why it is less stable. So these are the conformations of butane. I'll meet you again in the next video with the conformations of cycloalkane. Right. So we will also draw the order of stability for different cyclocompounds in terms of chair form and boat form. Thank you for watching, students. Stay connected, stay tuned.